Hi, I'm Miss Hall, and this is Lesson 66, Sums of Infinite Geometric Series. So, we're going to call these partial sums of an infinite geometric series. The sum S sub n of the first n terms of an infinite series is called a partial sum. The partial sums of an infinite geometric series may approach a limiting value. Example 1 will begin by looking at a pattern in partial sums. So we're going to consider the infinite geometric series 1/2 plus 1/4 plus 1/8 plus 1/16, so on. You'll see that we're dividing by 2 each time, or we have a common ratio of 1/2. And it says find and graph the partial sums for n of 1 all the way to 5, then describe what happens to S of n as n increases. Okay, so we'll begin with the partial sum of one term. So if we add half to nothing, we get half. The partial sum of two terms of this series is going to be 1/2 plus 1/4. Common denominator here is 4. So this will be 2. And our partial sum will be 3/4. S of 3, it's going to be adding the first three terms, 1/2 plus 1/4 plus 1/8 equals. Common denominator is 8, multiplied by 2. 8, we're multiplying by 4. This is 7/8. Partial sum of 4 terms will be 1/2 plus 1/4 plus 1/8 plus 1/16. You might start seeing a pattern. We have a common denominator of 16. So what do I multiply each by? The first one by 2, second one by 4, third one by 8. 8 plus 4 is 12, 14. This is going to be 15/16. Partial sums of the first 5 terms. It's going to be 1/2 plus 1/4 plus 1/8 plus 1/16 plus 1/32. Common denominator is 32. Alternatively, you could add these in your calculator. Multiply by 2, by 4, by 8, by 16. Add these all up, and you get 31 out of 32. So you can see that S of n is approaching one as n increases. Okay. And it's already been graphed for us. So what do we get for 1? We got 0.5, 2, 3/4, then 7/8, and 15/16, then 31/32. So it's getting closer and closer. It's never going to reach 1. It's getting very close to 1. In example 1, we discovered a core concept that the sum of an infinite geometric series with a first term, a sub 1, and a common ratio r is given by s equals a sub 1 over 1 minus r, provided the absolute value of r, this common ratio, is less than 1. If r, the absolute value of r, is greater than or equal to 1, then the series has no sum. So if you think about example 1, our first term was 1/2. Our r value was 1/2. That absolute value is less than 1. So we could have put 1/2 over 1 minus 1/2, which would be 1/2 over negative 1/2. No, positive 1/2, which equals 1. So that is what the sum is, roughly 1. We're going to find the sum of each infinite geometric series in example 2. Before we do that, let me tell you, so this formula is not on the reference sheet. I couldn't find it on a previous Regents exam, and that's why I saved it till after this unit exam, because we ran out of time, and because this is one that's not featured. You're not expected to memorize this formula, but I wanted to expose you to it, and you should be able to apply it in this lesson and in class. So we need to know the first term and the common ratio. Maybe important to start with the common ratio. In example A, it is 0.7. The absolute value of that is less than 1, so we can continue. The first term, if I set I to 1, 0.7 to the 0 power is going to be 1, so the first term is 3. Now the sum of this geometric series is the first term over 1 minus the common ratio is 3 over 0.3. Good, 10. So the sum of that infinite geometric series is 10. Now this next one has a common ratio of 3. Right? Divide the second term. Take the second term and divide it by the first term, and you'll get the common ratio. And the first term is 1. Hold up. This won't work. The absolute value of R is greater than 1, so we can't apply this. This series has no sum. It just keeps growing and growing and growing. So can't use it. And now C. I'll take negative 3/4 divided by 1 equals negative 3/4. And to be honest with you, I never just do 1. I check the third to the second just to make sure I get a common ratio. I don't get some other value. Divided by 3/4. 9 over 16 times 4/3. Don't have a calculator, so I'm going to take the division and switch it to multiplying by the reciprocal and divide both numerator and denominator by 4 and 3. And where did I miss the negative sign? Oh, this is a negative 3/4. So this is negative 3/4. Okay, so my common ratio is negative 3/4. And my first term is 1. Plugging it in, it is 1 over 1 minus negative 3/4. That's my R. 1 over 1 3/4, or 7/4, and this will be 4/7. Example 3, solving a real-world problem. A pendulum that is released to swing freely travels 18 inches on the first swing. On each successive swing, the pendulum travels 80% of the distance of the previous swing. What is the total distance of the pendulum swings? So they gave us a diagram and the geometric rule. So for this one, it is 18 times 0.8 to the n minus 1. This is the first swing, second, third, fourth. And we're supposed to find the S sub n, or just the sum of this series. So we need the first term and the rate, or the common ratio. The first term is 18. The common ratio is 0.8. The absolute value of 0.8 is less than 1, so we can use this formula. 18 over 1 minus 0.8. 18 over 0.2. And this is 90. And the units is inches. So in total, this pendulum swings 90 inches.